Albert, I lived hundreds of years before you, and you were able to use my work to develop your famous equation E=mc². It is true, Sir Isaac. Thank you for your excellent work on the three laws of motion. Scientists will always be in your debt. Would you like to share with me your three laws? I would be delighted to, Albert, or should I say, Dr. Einstein. Please, just call me Albert. And, by the way, do you like my office here at Princeton University? It's lovely. The first law states that an object at rest will remain at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This law is often called the law of inertia. Very interesting. In other words, this means that there is a natural tendency of objects to keep on doing what they are doing. All objects resist changes in their state of motion. In the absence of an unbalanced force, an object in motion will maintain the state of motion. The second law states that acceleration is produced when the force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. Can you guess what it means? Everyone unconsciously knows the second law. Everyone knows that heavier objects require more force to move the same distance as lighter objects. A good way to remember it is the F=Massachusetts equation. Excellent, Albert. Now, for the third law. For every action there is an equal and opposite reaction. Ah yes, the third law. It means that for every force there is a reaction force that is equal in size, but opposite in direction. That is to say that whenever an object pushes another object, it gets pushed back in the opposite direction equally hard. Good. I hope the students in Mr. D's class remember these laws. They form the foundation for much of the physics they could study one day. Physics is a fascinating topic. Yes, it's a wonderful field of study. It helps us understand what is happening in faraway places like Gliese 581 grams and in tiny atoms in our fingernails. Amazing. They should watch the Jiggling Atoms video that features Richard Feynman.